Today's show is sponsored by BMC, and BMC wants to know, is your business on its A game? The A game is when systems are intelligent by learning from markets, where automation is paramount yet effortless, and when technology and people work as one in an enterprise. The A game is your business at its absolute best. BMC calls this the autonomous digital enterprise. Find out more at bmc.com/agame. That's bmc.com/agame.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody is doing well. We continue to roll along here in January of 2021. We are just going to jump right into Cloud News of the Week. We know there's a lot going on in the world. We've still got a raging pandemic, and we've got some things going on in the political spectrum. We're not going to hit on those today. I think you probably all are well aware of what's going on. But let's talk about Cloud News of the Week because, you know, a lot of times the year starts off slowly. We have got a lot to talk about. Actually, a lot of announcements, a lot of activity. So let's jump right into it. Kong, a company who has done quite a bit around both API gateways and service mesh, and is really kind of, right in the middle of the new cloud-native application development paradigms, raised $93 million. So new round of funding for them. $93 million. So big round of funding for Kong, who is both, like I said, in the API gateway business, also in the service mesh business, and really kind of, getting a lot of attention in terms of helping people build distributed applications. Second are a couple of acquisitions that happened. First is Red Hat acquired StackRox, who is in the cloud-native Kubernetes security space. This is going to add to Red Hat's OpenShift platform, so a platform that's already done very well in the enterprise Kubernetes space and hybrid and multi-cloud space. Adds StackRox more advanced sort of DevSecOps security technology to that platform. And also F5 acquired Volterra for $500 million. Volterra, another in the security space, API gateway space, network security space. So big acquisition for F5. So a couple of big rounds of funding, a couple of big acquisitions happening. So a lot, big kickoff for 2021. We're going to go ahead and jump into, right after the break, we're going to start talking about another one of our cloud look-aheads for 2021. This time we're going to talk about a topic that we've kind of scratched the surface on a little bit, but never really dove into. We're going to dive into event-driven application development and also flows and all the things surrounding more real-time types of applications. This applies to a whole lot of things, streaming applications, IoT, and so forth. So really looking forward to that after the break. Today's show is sponsored by Datadog, a real-time monitoring platform that unifies metrics, logs, and distributed request traces from your cloud containers and orchestration software. Track the health and performance of your dynamic containers, apps, and services with rich visualizations and machine learning-driven events. Datadog's Cluster Agent streamlines data collection from large container clusters and allows you to autoscale Kubernetes workloads based on any metric you're already collecting with Datadog. To start monitoring your container clusters, sign up for a free trial today, and Datadog will send you a free t-shirt. Visit datadog.com/cloudcast to get started. That's datadog.com/cloudcast. Today's show is sponsored by Okta. In these challenging times, we're all looking for simplicity, something that just works. The last thing you want to do is spend time building authentication for your new curbside pickup app. Because if you're spending time building your own authentication systems, it's time spent not making your customers happy. This is where Okta makes it simple. Okta's cloud-based authentication services are easy to set up, and they already integrate with the tools and applications you use today. Okta is trusted by companies like HPE, Splunk, CarMax, GitLab, and Cengage, plus many, many more. To take the hassle out of your authentication needs, visit okta.com/cloud and learn how to get started today. That's okta.com/cloud. And we're back. And folks, as we've been doing here at the beginning of the year, and we did last year to sort of, great feedback from all of you, we're going to continue to do some of our kind of forward-looking shows, what we call our look-ahead shows for 2021. And one of the topics that I know Aaron and I have been, kind of talking about, loosely hinting at in various previous shows last year was this concept of event-driven, and, there's a lot of technologies that go around that, whether it's, Kafka and streaming and serverless and a lot of other things. IoT comes into play. And, one of the things we love to do is go find folks that are really into this space, really smart in this space. And we're excited to have a guest who's been a longtime friend of the show. And not only that, has just recently written a very, very good book by O'Reilly about this stuff. So very excited to have old friend of the show, James Urquhart, who is Global Field CTO for VMware, but also just friend of the Cloudcast. James, welcome to the show. Great to have you back on.
Well, thanks, Brian. I appreciate being here for sure. It's always good to be part of the show, and I'm really excited to talk about the event-driven architectures.
Yeah, so we've known you for a long time. You and I actually briefly worked together at Cisco. God, it feels like almost a decade ago. You've gone on to do a lot of very cool things, some startup stuff, some stuff at AWS, and what you did, at Pivotal and VMware. But I've always known you as the guy who loved getting into kind of complex systems, distributed systems. Give folks a sense of sort of what got you excited about really digging into this whole event-driven distributed space over the last couple of years.
Yeah, I think that, I think you kind of hinted at the core of it for me. So I've been a distributed systems practitioner and buff, for lack of a better term, really interested in the building and operation of large-scale distributed systems for a very long time. In the late 1990s, I worked for a company called Forte Software that was a 4GL development environment that did some of the, at the time, larger scale systems that were out there. This is back when, having 10,000 users and 100 or 200 concurrent users was like a really hard thing to achieve. But we helped in some ways at Forte to push some of the patterns a little bit more broadly among enterprise developers at the time. And from there, I've done a huge range of different roles. But at one point, I read a book about complex adaptive systems or complex systems in general, and it was just an eye opener for me. The fact that scientists have been discovering for decades now that among all these different fields that we study, there are certain systems that reach a point where they have very, very similar properties in terms of how they organize, in terms of how emergent behaviors occur, what the problems are in trying to predict anything about them, what the problems are in trying to predict anything about their shape or even observe them. Which sounded to me very, very much like maybe not at the time any given enterprise's distributed systems, but certainly the internet. And as we became more and more integrated, which is a key part of the topic we'll talk about today, as systems became more and more integrated across organization boundaries, then I found myself more and more interested in how our economy, the automation of our economy through business software, was being driven by complex adaptive systems type behaviors. And there's a myriad of them that we can talk about. So, and it served me well. I have to say, for folks that may not spend a lot of time thinking about complex systems or what that means or what scientists have discovered about these systems and how they measure, I have to say that you should spend some time on it, because the observations and the ways of thinking about how how to organize, how systems organize, what you can and cannot do in terms of managing systems, has really turned out to be very valuable in terms of my own career, in terms of the advice that I give our customers and clients as well.
Yeah, we're gonna dig into a little bit of that. So let's kind of start at the beginning for anybody that's not super familiar with this concept of event-driven and flows and kind of the basics around it. Like, where did it come from? What does it do? And ultimately, like, why is it important for people building, important applications, right? Things that drive our economy, drive people's business.
Right. So at the highest possible level, the space that we're talking about is really around real-time communication of things that are happening from one independent entity to another independent entity. And so an event, at its very simplest definition, is really a communication, a signal describing a state change. And that could be the creation of new state, that could be the change to an existing piece of state. But it's basically something that says, hey, the temperature changed by some delta, or there's a new speed that's being read from the front wheels of your car, or any number of other things. And so it's the core of what event-driven systems are is really around real-time state awareness and real-time situational awareness around state change. So the concept of event-driven systems have been around for a long time, right? The first messaging systems that were out there in the 1990s that were used by financial services companies and others to manage large amounts of traffic being communicated between systems. The first set of that stuff was really about event communication. We call them messages. There are messages that are used now that aren't so much about state change. So messaging has sort of broader, but the first messages that really mattered were about state change. And so this isn't, a new event-driven architectures aren't a new concept in their entirety, but what is new is that we are understanding and developing the scale and the capability of processing to handle massively large streams in time frames that work for having near real-time understanding and visibility of what's going on with the system, and being able to find the right thing to query for the right information at the right time, right? So whereas before, maybe if we knew that A needed to talk to B, we could set up that message connection and we could deal with that. And then messaging systems let us say, well, we know that A needs to publish to a topic and B needs to subscribe to that topic. So that's all great. So we can build a fairly static architecture that uses that communication system. But now the internet itself just means that there are many, many applications out there where you don't know when clients are going to connect or disconnect, or even data sources are going to connect and disconnect. So we're seeing this sort of ability now for systems to handle not only the flow of information and the processing of information through a stream, but also the connections and deconnections to the consumption of that stream at very, very large scales, at scales that really begin to change the story for things that have been done in business either by human action or by batch processing for a very long time. Yeah. And so that ability to see things in real time, I'll give you a quick story that kind of shows the impact of this. So when I worked at a company called Sosta that was acquired later by Akamai, that did real-time performance monitoring, so real user monitoring of browser interactions and the performance of browser interactions with customers. Mm-hmm. So RUM, or real user management, is really about collecting data from every browser interaction and every single load of every single element on a page in that interaction, collecting all that information and then storing it so that it can be analyzed as sort of a group with all the other interactions. And used to debug problems. But if you think about it, so our customers included some of the largest media companies out there. And if you think about it, the volume of traffic that represents, especially when something huge happens, and it was media and retail, it's a big sale, Black Friday's going on, or there's a big news event, or there's a big entertainment event going on. That's a massive amount of traffic that has to be processed. And what traditionally would happen in, say, the retail space is people would say, okay, well, we're going to do a campaign, and we're going to have our campaign tell, say, Google Analytics or some other system that we're using, maybe Adobe, have the sense of information specifically about the campaign. And then 24 hours after the campaign's done, we'll get our reports that tell us what all that information told us, right? So we can't do anything about the campaign while the campaign's running, but we can learn about the campaign after it's done. The big change that happened with Sosta was that we began to say, hey, all that performance data we're capturing from the browser also tells us about navigation. It tells us about time spent on a page. It tells us a whole bunch of useful information for measuring campaigns. So we started to provide dashboards that did correlation overlays between things like page performance and conversion rates, or a number of other things that were kind of related more. And all of a sudden, marketing people could see, hey, we've got a problem in this page, and maybe maybe the button's not in the obvious place, or there's something that's not working as well for here as we want it to. Let's try a change and put it out there while the campaign's still running, and observe what's happening within seconds or minutes of that change. And that was huge. I mean, we had marketing people standing down in the web operations centers of the IT department saying, can we get some of our people some desks in front of these screens so that they can see what's going on? And so that real-time effect is really what's going to drive event-driven architectures, because it's about being able to process these state changes as they come through and making them readily available and powerful. So the concept of flow that my book is about then is the concept of what happens when the interfaces and protocols to connect to a stream of real-time data, of event data. What happens when those interfaces and protocols become so standard that people can just point a standard library at a stream and instantly begin to process the information that's sent from the other side? If it's as easy to use as HTTP is today in all the software systems that we run, what happens when it becomes that simple?
Yeah.
And and that's really, that's kind of the core. That's kind of the core idea of flow with relation to event-driven architecture.
Interesting. Yeah. No. And I mean, there was a lot going on that I was, as I was listening to you go through, there was a lot of things that sort of jumped to mind. Right. There's, it sounds like this is part of this is kind of an evolution of things like batch, in that we used to think of, I can't process, I have this thing I have to do a lot of, but I can't process it in real time. So I have to think about it as sort of a, later on I'll process it. It's not a big deal. We're now sort of inclined as a culture to expect things in more real time, right? So there's a part of it that's an evolution of that. There's a part of this that feels like, and I know we've talked about this concept before on the show. It may have been a while, like this OODA or ODO loop, where you're making adjustments on the fly in real time. You're looking at what your adversary is doing or the market is doing, and being able to adapt to that in real time. It feels like there's a piece of that built into here, and then the other piece that I think is part of flows, but maybe I'm mistaken, is like there's also this concept that it doesn't all have to be real time. Like there's a piece of this could be, what if I want to replay this because I want to prepare for the next campaign? And so there's a lot of interesting elements of this that are, like you said, they're not completely new concepts, but the underlying technologies, the ability to process stuff has evolved such that we can now think about it in new ways.
Yeah, I think you're absolutely right. I mean, one of the things that in one of the chapters of the book, towards the last chapter, is about sort of picking apart what you can do today to prepare for this future, where connecting to streams is super simple and cheap to do. And a big part of that is choosing what form of stream processing you want to do, right? And so to your point, there are forms of stream processing where memory is incredibly important, where the ability to go back and replay is something that's really, really valuable. There are forms of processing that are, frankly, they don't scale as well, but they're frankly two-way conversations between two entities that have to know about each other and know how to communicate with each other. And then there's the other, far end extremes are really sort of some of the things you're starting to see with things like swim.ai and some of the other in-memory processing stuff that can happen out there, where you can just build a full digital twin model of your environment, of a very large scale environment, and be able to apply a number of basically adaptive reasoning technology to how those agents interact with each other, and what actions they take when they see certain state changes happening in their neighbors or in their, in systems that they're tending to, or whatever it may be. And I'm told of systems now where, like, entire major cell phone network companies have every single cell phone on every single every single tower, and every single transmitter and receiver involved in their network modeled in a single model, in a way that they can very quickly understand and affect the ways that these systems work with each other, and find and identify potential issues well before they become something that's noticeable by the end customer. And so that kind of processing, where the state of your system, of a large scale system, very, very quickly in memory, doesn't tend to go back and look at the past as much, but it's super duper powerful, right? In being able to build, say, AI rule sets that the agents can use that can very quickly kind of determine what do I do if I see pattern X occur in, at a given time. And another good example of that is like traffic management systems in a large city. How do you make sure the intersections are actually fairly optimal in the way that they're allowing traffic through those intersections? And you can build some really powerful technologies around that were not possible. And frankly, when you were just looking at, each action is a data stream, is a series of steps that the data has to go through from beginning to end to get to an end outcome, right? This is something where the system sort of builds an emergent behavior out of the behavior of the agents underneath. So it's a broad set of stuff that's out there. And I have a model that Clemens Vasters, who's sort of the chief messaging services architect at Microsoft Azure. I'm sure that's not his official title, but that's what he does. And he sort of stepped me through a model about why does Microsoft have 4 different messaging / event processing engines available as services. And there's a decision tree that he stepped me through that makes total sense. That says, if this is the case, then you should use A. If not, then you evaluate the next question, and that gives you another choice, or you evaluate another question, and the end result is that there will be many technologies that are part of this, and there will be many uses of these technologies that will be part of it.
Yeah, it's a little bit like we went from almost exclusively having relational databases to now people are picking and choosing from 8-10 different types of things, and it sounds like it applies to this to the same. Let me do this, because there's always folks that are kind of tune in because they want to learn about what's new, and then there's part of it that's like, okay, how would I actually do this? Can you just send look, there isn't one stack, technology stack that accomplishes all this, but can you kind of walk me through for, kind of a given example, like what parts of the technology stack we're talking about? I mean, is Kafka kind of predominant? Is it NATS? Is it other, what are you seeing kind of commonly used in a typical stack?
Yeah, well, it's sort of an all of the above, in some sense, but so in order to kind of make the case that I'm making about these flow interfaces, I did a lot of work with something called wordling mapping, which I'm sure the show has covered at some point in time, and promise theory, which is a really brilliant sort of algebra for cooperation in disparate distributed systems, and so. In using the two together, I was able to kind of identify, for the purposes of the book, a set of 14 components that I argue, are the makeup of what's needed for this flow concept, for this concept of these standard interfaces and everybody, easily connecting to event streams to come to fruition. And the key ones, the critical ones, are sinks or sources and sinks, right? So sources of data that generate new events, sinks, which are sort of final resting places that events will go in one way or another that sort of terminate a stream. And then in between, really the need for the connection itself, the ability, basically the ability to establish a connection with between a producer and a consumer, or an underlying set of agents working on behalf of the producer and the consumer, and then the processing and the queuing that's necessary in order for a flow to be maintained without having either overwhelming consumers with flow with information and losing data that way, or losing memory if memory is important to you, right? Losing the history of events that have occurred if that's important to you. And so processors, queues, sources, sinks, and the connection are really the baseline of what makes up a flow environment. So in the processor section, in the queue section, I would say that the kind of the real big players right now are in general are sort of the message queue and message bus folks are sort of the place that people go to when they think about event processing, but the major cloud providers have come in and disrupted that completely. So where you see the more modern applications being built are largely Amazon, Microsoft, and Google with the sets of services they have for the different use cases that are readily available to be consumed on demand. Kafka is an important exception to that, meaning they are also a major player, absolutely, in the space. I think, and I just kind of throw out there that I think there's a danger with Kafka right now that people are attempting to put types of processing and do types of processing with Kafka that would be better served by a different model. But I think that will sort itself out as the market and other areas grow. And I think so. I think that's a fairly sophisticated. And then you've got this sort of growth of a combination of function as a service, things like Lambda, and even step functions. Another AWS service that does more of a process-oriented view of how to handle an event. And then so you've got those kinds of things, and then also sort of the low code, no code space is starting to have some event specific technologies that are out there. Vantic is one that stands out for me fairly quickly as something that allows you to kind of put together processing for a flow without having to write a ton of code, and does very sophisticated things like it gives you the ability to have a directory of available streams that your developers can go figure out what to connect to and what are the volumes of traffic they can expect, what are the technologies, the security technologies, encryption technologies involved, and so on. And then the last category is this sort of digital twin model stuff that I talked about earlier as well. So swim.ai, I think, stands out for me, but I'm starting to hear about other technologies that are out there. They're trying to play in the same space. Many of them are a little bit more data stream processing as opposed to digital twin models, but they're close. They're not very far away from that model set.
Yeah.
And that shouldn't be surprising. That's kind of the baseline of those technologies that are in the processing and queuing space.
Yeah. Yeah. Well, and the Swim AI thing shouldn't surprise anybody. Simon's brilliant, always surrounds himself with very, very smart people. So, it's interesting. And I know you and I were talking, ahead of time, a lot of this stuff, some of it, the pieces are more mature, or they're maturing, fairly mature. And then, like you said, there's going to be a whole ecosystem of sort of new interfaces and protocols that, as things move to the edge, become lower power processing things. You always get a whole lot of adaptation that has to happen, to that what you do in the cloud or what you do on, sort of high bandwidth links or high processing devices is going to be different than if you have, a different set of devices that just have different characteristics. You may have to create different security model, different, communication protocols, different frequency at which they can process stuff and everything. So I'm curious. So, we've scratched the surface a little bit on the tech, kind of what it is, where it's going. As you talk to business leaders, like sometimes when I find that when I talk to I talk to business leader about new stuff, you kind of have to boil it down to something simple, right? So like, cloud made IT sort of self-service, serverless came along years later and sort of said, hey, you don't really have to think about operations anymore. It's sort of built in. Like, what do you find is sort of the elevator pitch that you might make to a business executive as to why this event-driven, flow-based stuff is really important and significant change?
Yeah, it's two elements. One is the real-time story, right? So get rid of overnight batch processing of stuff where if you had the information that day, you could actually take advantage of it and do more, right? So that's one piece of it for sure. But I said the other part of it too is I did a blog post more than 10 years ago now about the kind of contrasting composable systems with contextual systems. So I'll start with sort of the contextual systems are systems that the platform defines the process by which things happen and then provides mechanisms where you can plug in your specific decision, your specific customization at specific points in that overall flow and process. So it says, this is step 1, step 2, step 3, and then you can say, okay, this is what I want to do in step 1. This is what I want to do at step 2. But the platform defines how the information flows through all those different steps that are going to happen. Contextual systems are a little bit more like the Linux command line and piping, where you have a bunch of small components that do certain things very, very well, and you're able to string them together in a myriad of different ways and pass consistent information, in between, in a way that each component knows how to process the input that comes in. Even if it's blind to the meaning of that input, it knows how to process it, and then it knows how to output it so that it can be consumed by the next thing that you chain together. And so the other piece of this to me that I think is really important is that ability to say, we are able to now sort of say, let's stack the next thing on the chain without having to revise and modify the application, the components that are earlier in the chain. That we can actually take pre-built elements and decide how to put them together. And when I say pre-built, it could be something that's custom within a certain organization. It could be, I believe, a growing market of services and capabilities that will be built on top of Flow, that will enable for crazy levels of new processing. Imagine this, right now when people outsource something in the business, they usually outsource an entire process, right? They usually outsource, HR payroll. They outsource, in manufacturing, you may outsource the design confirmation portion of your, say you have a printing shop or a printed circuit board shop or something. Imagine if you could actually just outsource the specific commodity steps of a process while maintaining the process and running the process yourself, so that instead of outsourcing all of payroll and sort of handing off massive amounts of information to somebody who you have to adapt to their process as they go, you could say, you know what, I want to outsource the tax verification steps. I want to outsource, obviously, the financial portion of it, the printing of the checks, but I want to keep in-house perhaps the ability to generate some content that gets added to the pay envelope or to the is sent alongside when the email that's sent whenever a direct deposit happens or whatever it may be. Yeah. So that ability to sort of begin to compose in a new way and in a more agile way is a big piece. Also, being able to include stuff that was too expensive to integrate with in the past is a really, really big one as well. So I do talk a fair amount about like the logistics industry and the trucking industry, and they've been digitizing like crazy. They're probably in some ways farther along in standardizing interfaces than many are. But the reason they are is because they have this huge problem in how do you coordinate, weather and road traffic and available capacity in the truck and availability of a driver and, the mechanical condition of the truck. How do you coordinate all of that to identify an opportunity to serve a customer that has a shipment that they want to take, say, from Toledo to Jacksonville, Florida, right? Right. And so that ability to sort of get that information in real time and be able to beat your competitors at making a decision that gets you the business is really going to be a big, big driver for a lot of this. And I think, to me, that's that granularity of that for a business, the real value proposition is going to be being able to serve your customers better and even anticipate their needs in faster and sooner and in a more real-time situation, while the cost of getting access to the information that allows you to do that goes down. Yep. And it becomes much simpler and much cheaper, both from a technology development perspective and from potentially from the cost of the data itself, from anybody who's charging for access to the data, that those costs will begin to find a market presence that will make that very cost effective. So That's what I would say is kind of the key business driver there. It's a change from this idea that we have to do everything very large grain and with a lot of planning on how we integrate with other businesses. And where we can proactively say, instead of saying, hey, we have an API, let's go convince people to write to our API, you can very proactively go out there and go, hey, I just want, you know what, I want to go get that data. If they make it available to me, I want to just go ahead and receive it. It doesn't replace APIs. I think it replaces very little in what we do today besides batch processing.
Yeah, no, but it's a very
it does
different way of
add
thinking
a
about
tremendous amount of flexibility to how you can, and speed to how quickly you can respond to customer needs and a variety of other factors.
Right. One last question, I'll let you go because I know we're going to kind of run out of time here a little bit. We've covered a lot of sort of the, why it's important, what is it, for anybody who's like, okay, this is really kind of piqued my interest. What are maybe one or two things, maybe technologies or, kind of concepts within this space that you're really watching, this year and next year that you think have an opportunity to really get interesting, really get exciting, really kind of change this landscape?
One is there's a lot going on in the standards world that I think is worth watching. So the number one thing I always tell people about, if you're really interested in flow, go pay attention to the cloud event specification that's about to reach it's been out as version 1 since last November, and I think they're very close to getting it sort of a 1.1 out if they haven't already done that. Which is being adopted quickly by not only cloud providers, although I think AWS is a little slower than I would have expected them to be, but you see it in Azure already, you see it in Google Cloud already. You also see it in things like the CI, Kubernetes-friendly CI environment, Tecton. You see it, a number of other places that are emitting cloud event capability. It's not the winner by any means, but it's defined really well for this purpose, and it has a good chance. It's basically a metadata standard format so you can describe the context in which a payload describes an event. And it's so that's one area that I always point to. And another area I think is really exciting is there are a couple of companies out there that are working on interesting ways of changing the way the internet works to support these kinds of connections. One is, so you talked about Nats.io. Derek Collison, one of the creators of Nats.io, has a company called Synadia that is very interestingly kind of putting together a underlying infrastructure for either network service providers or for others to essentially put together a simple way to connect to streams globally. So rather than having to have a URL for an endpoint and an API at that endpoint in order to know how to connect and a number of other things, simply you connect to the front end for the cloud environment, and you simply say, hey, here's the URI of the stream I want to subscribe to. And the underlying infrastructure figures out what's the closest node that I should connect you to. What are the encryption, decryption things and security things that have to happen. Very, very security focused technology they're putting together. And so that's what I put together. That's what I kind of look at as sort of two companies that stand out to me as being really interesting. But if you really want to understand and help drive forward what's going on with event-driven systems, so that this flow kind of concept can come to fruition, I definitely think that open source communities, Kafka is not the only one by any means. A number of open source communities plus some of the standards bodies are slowly starting to show that there's some ideas taking shape here, and it's worth looking at those. And one last thing I'll say about that is also, if you're in an industry association of some sort, one of the hardest problems in this flow problem is that the payload formats are going to have to be are also going to have to be standardized, or should, are likely to be standardized in order to make them simpler to consume for very common transactions within a given industry, right? So my guess is that much like the way EDI worked, much the way that financial services exchange protocols worked, we're going to find that industries are going to come together and define data formats that work really well as, say, a cloud event payload, or as an MQTT payload, or whatever it may be, so that others in the industry don't even have to write code in order to be able to process that data. Right? There'll be readily available libraries to make handling that data, or even applications to make handling that data easily. So, that's another area where people can get involved now, is just saying, look, are we prepared for an event-driven future in our industry? What do we need to do to be prepared to exchange information in a timely fashion, right? We don't want to build up a huge, giant document of information every single time, but at the same time is also something that we can all understand and consume and transmit to each other safely and easily.
Yeah, good stuff. Good stuff. Lot to chew on there, folks. Just a couple of other things I'll throw in there. We had both Swim AI and Derek Collison on the show in the past. We'll throw the link to that in the show notes. James, real quick before I let you go, give a quick plug for the book. I know everything I've ever seen you write is incredibly well thought through. So give us the name of the book, where people can find it, and probably most importantly, how they can reach out to you if they have questions.
Yeah, the title is Flow Architectures, The Future of Event-Driven Integration, published by O'Reilly Publishing. The Kindle version is available on Amazon today, as of the recording of this podcast, and then and the print version will be available within the next week or two. Amazon's a good place to find it. O'Reilly's, if you're an O'Reilly subscriber, you can start reading it today on O'Reilly's website as a part of your subscription. And it'll be available pretty much everywhere you can find an O'Reilly book within the next few weeks. So I encourage everybody to, if this is an interesting topic to you, please take a look at it. It's meant to drive thought. It's meant to trigger a conversation in the industry and help folks begin to say, there's some adaptation that we could do ahead of time that would give us some advantages in the future. And I hope folks will take the time to pay attention to that.
Yeah, good stuff. Good stuff as always, James. It was great to catch up with you. It's been far, far too long, folks. With that, I'm going to wrap up the show. For myself and Aaron, I want to thank James for his time today. As always, I want to thank all of you for listening to the show, for telling a friend and sort of spreading the community, helping us grow the show, giving us feedback on iTunes or Apple Podcasts, everywhere else you listen to the show. So with that, I'm going to thank James for his time, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.